Today we will analyze the response of parallel RC circuit to sawtooth voltage input. Consider an RC circuit. Resistor is equal to 1 kilo ohms, capacitor is 1 nanofarads. Input is a sawtooth waveform with amplitude 1 volts and time period to be 1 milliseconds. Since R and C are in parallel, the voltage seen across them will be same as input voltage. We want to find the current flowing through the capacitor. Current flowing through the resistor will be VR by R, and hence its waveform will also look similar to the input voltage waveform because VR is equal to Vin. Now to find the current flowing through the capacitor, here is the equation. IC is equal to CdVC by dt. On substituting the following parameters and on plotting the current flowing through the capacitor values, we can see how the graph looks like. And the Vin can be calculated using V peak into T real by T period. Now the same calculation for current flowing through capacitor is repeated in Excel with time intervals of 200 microseconds. Let's look at that. This is the input that we are feeding to the RC circuit. T rise is the time required for the input voltage to rise from 0 to 1 volts. Here it is 999.9 microseconds, which is equal to 1 milliseconds. T fall is 1 nanoseconds. On plotting current flowing through the capacitor, this is how it looks like. Vin can be calculated as V peak into T real by T period. And for 5 microseconds, it is equal to C into dV by dt. Now on simulating this, we can see that this is the input voltage that we are feeding to this parallel RC circuit. And if we observe the current flowing through the circuit, it has reached 1 microamperes and it is there in the steady state of 1 microampere up to 1 milliseconds. This is because the input keeps changing in a sawtooth waveform, and hence dV by dt will not be 0. It keeps changing, and hence we can see that current is 1 microampere. And when the input voltage drops down to 0, there is a significant difference between 1 volt and 0 volt, and hence there is a current spike seen which reaches minus 1 microampere. Here is the summary. We can see how the input voltage has transformed the current flowing through the capacitor. If the time constant of the RC circuit is comparable to input's time period, then it will not resemble the behavior for sawtooth voltage input. Thank you for watching this video.